Greetings and welcome. This is Dr.BDY Sunil, Associate Professor, Mechanical Engineering Department, Institute of Aeronautical Engineering, Hyderabad. In this session, we will be learning about the DAlemberts principle and its application in plane motion. The course outcome for the topic would be apply DAlemberts principle to a dynamic equilibrium system by introducing the inertia force for knowing the acceleration and forces involved in the system. The topic covered would be DAlemberts principle and its application in plane motion. The topic learning outcome is application of DAlemberts principle to engineering problems and know the effect of forces in the movement of the bodies. So first let us understand what the DAlemberts principle states. The statement given would be system of forces acting on a body in motion is in dynamic equilibrium with the inertia force of the body. This is the DAlemberts principle which we will use for solving the weak kinetic problems. Right? So in the statement there are three important terms. One is system of forces. So there would be forces involved in the system and body in motion. So the object which is involved in this system will be having the movement. The object which is having the movement is involved in the system. Then this dynamic equilibrium condition is the condition where even though the object is moving, the object is in equilibrium condition. So these three are the important terms that are involved in the DAlemberts principle, where the dynamic equilibrium state will be achieved by the system because of inertia force. Because of inertia force of the body. So this is what the DAlemberts principle says. For understanding this, first let us try to understand what the object will be like in the movement while in the system. So let us take a example of a bus carrying so many passengers. We all know that when the bus takes a right or left turn, then because of the inertia, the objects that the passengers that are involved in the bus, they will be moving towards left side while the object is turning towards right side. And when the bus is turning towards left side, the passengers will be moving towards right side. Right. So in this example, we can say while the bus is taking a turn, there are number of forces that are involved, which makes the bus to take it, like the involvement of the traction between the tires and the road, and the involvement of force that being applied onto the tires or wheels by the axle using the steering. Right, all these forces which are involved in the system are making the bus to turn towards left or right. So when this is happening, the bus will try to move towards, the whole bus will try to move towards left or right. This we have seen in our general observation, right? While the bus is taking a turn towards right side, the bus will try to move in the left side direction. That means the position, the center position of the bus will be converted to the left side while taking a right side turn, and right side while taking a left side turn. But even though number of forces are acting on the bus, as we have discussed, the bus is not controlling out, right? The bus will be in a stable situation or stable condition even though number of forces are acting. So this is the case where even number of forces are acting, and because of that the object, the bus is moving. When the bus is having a dynamic condition, the stability of the bus is not missing. That means the bus is not rolling out or falling out anything. So that's what the equilibrium state of the bus in dynamic way is considered. So this dynamic states condition will be achieved because of the inertia forces that are involved in the body itself. And this inertia forces that are involved in the system will be making the system into dynamic equilibrium state. So as the statement states, system of forces acting on a body in motion is in dynamic equilibrium with the inertia force of the body. So the dynamic state of the object is happening, but it will be in equilibrium condition, which is involved with the inertia force. So it can be given as R minus ma is equal to 0, where this ma, mass into acceleration, is termed as the inertia force, and R is the resultant force, that number of forces are acting in the system, and this R will be considered as the resultant force. Okay, so where R is the resultant of all the forces acting on the body, and the term minus ma may be looked as force of magnitude mass into acceleration, force of magnitude m into a, applied in the opposite direction of motion, and is termed as the inertia force or reverse effective force. So this term minus ma is called as the inertia force. So the statement, the given statement by DAlemberts is being given as R minus ma is equal to 0. So wherever there is movement is considered and the forces are involved in the system, then the inertia force comes into picture. So whenever we are solving the kinetic problems, we need to involve the inertia force so that the total system will be in dynamic equilibrium. And that inertia force is also in the negative direction, that is minus ma. So whatever direction the object is moving, or we can say the whatever direction the object is getting the acceleration or achieving the acceleration, the inertia force will be acting opposite to the achievement of the acceleration. That means, for example, let us say a body is being present, a body is being placed on the surface, and a force is being acting in the right side direction. And because of this force which is acting in the right side direction, the body will move towards the right side. That means the body is achieving an acceleration, right? This is the force applied, and this is the direction of the movement, of object. Then we can say that the body is achieving an acceleration in the right side direction. Okay, so now for the implementation of the inertia force, always we will be considering the direction of the inertia force opposite to the direction of the acceleration. Opposite to the direction of the acceleration. That is the reason here we are considering it as minus a. If at all we consider the movement in acceleration's direction, then what we can take? Directly we can take it as ma, which will give minus ma, which will give the result of this minus ma term, that is inertia force term. But while solving the problem, it becomes somewhat difficult to represent it as minus ma at each and every places. So what we will take for the movement of the, or for the direction in which the acceleration is happening to any object, the direction in which the acceleration is happening to any object, we will consider, or we will represent the inertia force in the opposite direction to the acceleration of the object. Opposite direction to the acceleration of the object. This is how the inertia force will be involved in the concept of kinetic solving problems. So whenever there are problems that are related to kinetics, what we consider is the inertia term, the inertia force term will be involved in the system, and the representation of the inertia force will be in the opposite direction to the direction of the acceleration. So now let us understand the motion of a body on inclined plane. That means let us see how the inertia term will be involved in the movement of the object. Here, as you are seeing, there is an inclined plane. Okay, there is a plane which is inclined at an inclination of alpha to the horizontal. Alpha to the horizontal, and the weight of the object is acting vertically downwards. Okay. Also, here, as the involvement of forces are not present, but here the weight is acting as a force alone. So what we are doing? Let us consider this because of the inclination of the plane, the object will try to move towards downward direction. Let us say it is a smooth surface, and because of that smooth surface, what happens when the object is placed on an inclined plane, as there is no support here, no support for this object, then the object will try to move towards downward direction of the plane. So obviously we need to implement the inertia force. We need to implement the inertia force which is acting in the right side direction, nothing but opposite to the direction of the acceleration. Opposite to the direction of the acceleration. So this is how the representation of the inertia force will be given for smooth surface of the plane. Here you can see this weight W is being resolved into mutually perpendicular components here, right? Why is this happening? This is happening because this vertical force weight, this vertical force which is the weight of the object, will be inclined force for the case where this plane is inclined, right? So the object is placed on an inclined plane. That's the reason this weight is being resolved into mutually perpendicular components. And according to the triangle principles, we will be obtaining the inclination alpha here. So the component normal to the plane component would be W cos alpha, and along the plane component would be W sin alpha. So this is about the smooth surface and the consideration of inertia force in the system. Now let us see the rough surface. There is only difference between smooth surface and rough surface. Involvement of inertia force is same. We need to consider the acceleration direction, and we will be implementing the inertia force opposite to the direction of the acceleration. So for this rough surface, what we do is, this plane is represented as the rough surface. Nothing but there is a involvement of friction at the contact point of this body and the plane. Contact point of this body and the plane. So what we will do, we will be involving the concept of friction. Involving the concept of friction at this contact point. And now, in which direction the friction should be shown? Again, as we know, this is an inclined plane. We will be saying that this object will try to move in the downward direction. Object will try to move in the downward, slide down the plane. So obviously the direction of friction would be opposite to the movement of the object. So there is a difference. You please try to understand, there is a difference. For the friction value, for the friction, what we will consider? Opposite to the movement of the object. Opposite to movement of the object. That we need to consider for the direction of the friction. Coming to inertia force. Coming to inertia force, what we need to take? Opposite to the direction of acceleration. Opposite to the direction of acceleration. So you need to remember all these things, where the implementation of the certain phenomena like friction, acceleration due to gravity, and inertia force, all these terms needs the direction here. Very important case where the directions will be involved. So you need to be careful while considering the directions. So now, as per the given problem, the object is moving towards or sliding down the inclined plane. So the friction will be acting towards right side, up the plane. We can say it is up the plane. And coming to normal reaction, immediately when the friction is involved, the normal reaction will be placed, and that normal reaction is also towards the object. Towards the object. Now implementation of inertia force. What we are seeing here, object is trying to move down the plane. Nothing but the object is achieving the acceleration down the plane. So inertia force would be opposite to the acceleration. Opposite to the acceleration. So the value of MA would be towards up the plane. That's the difference which you need to consider. So this is how the free body diagrams for any systems that are involving in the kinetic problems will be shown, right? And the same case will be utilized for horizontal plane also. Let us say there is a horizontal plane and an object is placed here. As we have discussed previously, object is being applied with a force F. Then what happens? The inertia force will be acting towards left side direction because this object is accelerating towards right side direction. Okay, in this way we will be considering. We need to consider the direction in which the object is moving, nothing but the direction in which the object is achieving the acceleration. In most of the cases, we will be seeing that the object, let us say a car has been moving with certain velocity and brakes are being applied. When the brakes are applied onto a car or any vehicle, what happens? The acceleration decreases, isn't it? Or the speed decreases. We can say the speed decreases, velocity of the car decreases. This velocity of the car decreasing case is treated as the retardation or deceleration. Retardation or deceleration of the car. Let us say this is the road on which the car is traveling. Car is traveling in this direction with a velocity kilometers per hour. Let us take this as 70 kilometers per hour. That means this object is moving in right side direction, and suddenly at some point brakes are being applied, isn't it? Brakes are being applied, and at some distance, after certain distance, the car has come to stop. In this position, what we will consider, that speed is being decreased, nothing but car's velocity is decreasing and car is retarding, or the acceleration is in negative form. The vehicle is decelerating. So in this direction, the acceleration is decreasing. That means we can consider it as minus A. Okay, it is in negative condition. The acceleration is decreasing. So actually the opposite of this minus A, that is in which direction the acceleration is happening? Acceleration is happening in this direction. Okay, as this is a decelerating condition, nothing but the acceleration is happening in negative way, minus A. So the opposite of this thing would be positive A, and which will be happening in the left side direction. Even though the car is moving in right side direction, but the acceleration is happening in the left side direction. Nothing but actually it is decelerating in the right side direction. So we can consider opposite of this deceleration, which is in the left side direction, as the vehicle is accelerating in left side direction. So in this case, what we will apply? In this case, the inertia force will be applied as the acceleration is happening in left side direction. The inertia force will be applied in the right side direction. That is what important here. You need to understand that the inertia force should always be applied to the opposite direction of the acceleration. Deceleration is opposite of the acceleration, nothing but in the opposite direction the acceleration is happening, right? So the inertia force will be opposite to the acceleration. So that's the reason, even though this car is moving in right side direction, the inertia force is also being given in the right side direction. Why is this happened? Because there is a deceleration of this car. Nothing but the acceleration is in decreasing form. So these are the conditions and DAlemberts principle, important conditions which will be considered in the kinetic problems. This concludes the session. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.